Section 4.5 has to do with graphing linear equations. If you look at the word linear, you see that it has the word line in it. So these are equations that form lines. You've already been doing some of that in the last section. We're going to continue that mindset. We need to be able to identify when something is a linear equation. And all linear equations can be written in standard form. This is your standard form, where the a is a positive number, and a, b, and c are whole numbers, so integers, no decimals, no fractions, whose greatest common factor is 1, but the 1 got over to the side too far. So we want to be able to look through these linear equations, decide whether they are a linear equation, and if they are, to put them in standard form. When I look at this one, I can tell you it's not a linear equation because it has an x, y, and a z. A linear equation either has an x or a y, or it might be written as like a and b, but it only has two variables. Those variables cannot be multiplied together. The variables cannot be on the bottom of a fraction. They cannot be underneath a square root, and they cannot have an exponent larger than 1. So this is a no. This is not a linear equation. This is a linear equation, and in fact it's already in standard form because I have 3x minus 6y is equal to 27. You could rewrite that as 3x plus a negative 6y equals 27. So this is in standard form, and really the only thing you can do to it, and you don't even have to do that, is add the opposite of the second number to make that plus a negative 6. This one, it is a linear equation, but I have a little bit of problem with it because I have a fraction. So to get rid of my fraction, I want to multiply everything through by 4 because I have a 4 on the bottom of a fraction. That's going to give me 3x is equal to 4y plus 32. Well, to put it in standard form, I've got to get the x and the y value on the same side. So I'm going to add a negative 4x to both, or 4y to both sides. So I have 3x minus 4y, or you could say plus a negative 4y, equals 32. And that's in standard form. It matches that. This one, I have an x or a y, or an x plus a y, some sort of combination of it. I just can't have them multiplied. But it's okay if you just have an x or you just have a y. Again, though, I want to get rid of my fraction, so I'm going to multiply both sides by 4, so it's going to give me x is equal to negative 28. If you wanted to write it closer to that, you could write x plus 0y equals negative 28, but either one is accepted as standard form. This is a vertical line through where x is equal to negative 28, but we'll talk more about that at another time. When they tell you to graph making a table, this is very similar to what you just did in the last section, but you get to choose your own x values. So I come over here, the very first thing I do is I rearrange this to solve for y. So I'm going to add a negative x to both sides. So I have 2y equals negative x plus 6. I'm going to divide everything by 2. And it's going to give me a value of y equals negative 1/2 x plus 3. So that's the equation that I'm going to use. And I'm going to pick 3 different values for my x. Now I'm going to pick values that's going to make it easy to do the math on this. So let's pick, so I want whole numbers there so I can take the half of them. But I also will pick a 0, so let's do 0, 2, and 4 for this. So I have negative 1/2 times 0 plus 3. So that's going to give me a point of 0, 3. And I can do negative 1/2 times 2 plus 3. So half of 2 is 1. It's going to be a negative 1 plus 3 is a positive 2. And half of 4 is 2, and it's going to be negative. So I have a negative 2 plus 3, which is going to give me a 1. Now, so the only thing that's been different between this section and the section before is I get to choose my own values for the x. So now I put them on my graph. I have the point 0, 3, 2, 2, and 4, 1. So you can see that it would form a straight line. So that's the graph of that equation. Again, the first thing I did was rearrange it and solve for the y. Then I picked 3 values for x, so I could plug them in and figure out what the y value is for each of the x values. Here's another example. Again, the first thing we have to do is solve for the y. So I'm going to add a negative 4x to both sides. So I have 3y equals negative 4x plus 12. Then I'm going to divide everything by 3. So I get y is equal to negative 4/3 x plus 4. Again, I'm going to pick values that it's going to make it easier for me to do the math on it. So I'm going to pick negative 3, 0, and positive 3. So when I plug in negative 3, that right there is going to give me a positive 4 plus a positive 4, which is an 8. I'm going to multiply by 0, and I'm going to get y is equal to 4. And then I'll plug in a positive 3 here, which is going to give me a negative 4 plus 4, which is 0. So then when I plot these points, it's going to be hard for me to plot the negative 3, 8, but I'll give it a shot. This is 6, 7, 8. So that is approximately, I'll say it's right there. 0, 4 is right here, and 3, 0 is right here. So again, if you it would form a straight line. You could go ahead and draw it through there. I don't have a ruler, but let's see if I can. That's close. Okay. The other concept in this section is graphing using an x and a y intercept. Now, an x and a y intercept is where it crosses the x-axis and the y-axis. So an x-intercept is going to fall right on this line. A y-intercept is going to fall on this line. So I want to graph this equation using an x and y-intercept. An x-intercept, which would be on this line, would have a y value of 0. So that is the first thing I'm going to do, is I'm going to let y equal to 0. So I have 0 is equal to 2x plus 8. I'm going to solve for my x. If you want to switch sides here, you can. I'm going to add a negative 8 to both sides. So I have 2x is equal to negative 8. I'm going to divide by 2. And I'm going to get x is equal to negative 4. So this is the point negative 4, 0. So that's that point right there where it crosses the x-axis. Now, to find the y-intercept, I'm going to let x equal 0, because if it's on this line right here, it has a 0 value for x. So I take again the equation, and this time I substitute 0 where the x is, and it's going to give me y is equal to 8. So, and then I can draw a line to form my line through those. It's a little crooked, but you get the concept. Here's another example. It says graph using the x and the y-intercept. Again, for the x-intercept, I let the y equal 0. So I'm going to add 6 to both sides, and I'm going to get x is equal to 6. So that's going to be that spot right there. And then I'm going to let the x equal 0 for the y-intercept. So y is equal to 0 minus 6, or y equals negative 6. So down here, and so that's that line. It would help to use a ruler. I just don't happen to have one right here. All right, your homework is page 221, 16 through 36 even.